Here's your video set on doing stoichiometry going from moles to grams or grams to moles. So on that first reaction, our reaction type is a combustion reaction because we know we have a fuel plus oxygen and it yields carbon dioxide and water. So we're going to look at what we start with and what we need to go to. So we start with 4.35 moles of butane, which is what I need to put in the upper left-hand corner of my T-chart. And I know that because I have moles of butane here, I'm going to have moles of butane on the bottom. And then you ask yourself, can I go from moles of butane to grams of oxygen? And we do not have that conversion unit because anytime we go moles to grams, we know our compounds or elements here need to match. And so the only thing that we can go to here in order to get to grams of oxygen is we need to go to moles of oxygen. So I like to call this mole city. Again, our map to mole city is the balanced chemical formula. So here I know that from my formula I have 13 moles of oxygen, and here I have 2 moles of butane. So I'm going to fill in my values, and then I check to see, am I in the units that my problem is asking me to get to? So is moles of O2 what I need to get to? No, because I'm trying to get to grams of O2. So I need to extend my T-chart. So T-charts are really easy. We know that we need to simply make sure that we're looking at the units that we're in, and then asking, are we in the correct units? And if we are not, we'll need to do another T-chart conversion unit. So I'm going to put moles on the bottom here in order for those to cross out, and then you ask yourself, can I go from moles of oxygen to grams of oxygen? And I can indeed do this because anytime I go moles to grams, my elements or compounds here need to match. Anytime I have moles and grams in a T-chart, I know I have 1 mole, and then the mass of oxygen is a diatomic molecule, so 1 oxygen is 16 grams, so that means that 2 oxygens is 32 grams. And then you check to see, is the math in the correct units that the problem is asking me to get to? I'm asked for grams of oxygen, I'm left in grams of oxygen, so I am indeed done. It's in the correct units. So then I would multiply everything across, divide underneath, and that gets me the correct answer of 904.8 grams of oxygen. Alright, number 6 is the other example I'm going to do for grams to moles, moles to grams. Please ignore the answer to number 5. We'll check that together. I just need to show you number 6, so that just happens to be up. So just ignore the answer. So how many moles of aluminum are needed to make 44.4 grams of iron? So there's an example equation right above number 4 here that we're going to reference for us to be able to do our mole ratio. So I know that I need to start with 44.4 grams of iron, and I know I'm trying to get to moles of aluminum. So if I start with 44.4 grams of iron, I know that grams of iron needs to go on the bottom. And then you ask yourself, can I go from grams of iron to moles of aluminum? Anytime I go moles and grams, those elements or compounds need to match. So since they don't, what I need to go to is moles of iron. I never can go from grams of iron to grams of aluminum. Please don't ever do that. Grams of iron to grams of aluminum does not exist. There is no conversion factor for them. I should never see a gram over gram conversion in our T-charts when we're dealing with stoichiometry. So the thing that you need to go to, again, is moles of iron. So anytime I have moles over grams, I know that I have 1 mole, and then I have the molar mass of iron, which is 55.8 grams. And then I look at my units, so I'm in moles of iron, and I ask, am I done? My problem asked me to get to moles of aluminum, so I am not done. So I need to continue my T-chart, so I go from moles of iron on the bottom, and then you ask yourself, can I go from moles of iron to what my problem is asking me to get to, which is moles of aluminum? And I can indeed do that, because I now am in mole city, I'm in a mole to mole ratio here, and so I'm able to use the balanced chemical formula from the problem above number 4, or the equation above number 4, and I'm able to say that I've got 2 moles of iron to 2 moles of aluminum. If I cross my units out here, I'm in the correct units, moles of aluminum, that my problem is asking for. If I multiply across, and then divide, I should get 0.796 moles of aluminum. So there's your example problems on grams to moles or moles to grams stoichiometry.